You've probably seen this happen. A fantastic real-time app gets a bit of hype, starts getting popular, and then, boom, it just crashes and burns. Well, today, we're going to be detectives. We're going to uncover exactly why that happens and lay out the blueprint to make sure it never, ever happens to you. So here's the mystery. You've poured your heart into building an amazing WebRTC application. It works like a charm for 100 users. But the moment you hit 1,000, maybe 10,000, the whole thing just grinds to a halt. Connections start dropping, calls fail. It's a total meltdown. So what gives? All right, let's start our investigation at the most obvious place, the front door. We're talking about the signaling server. This is where every single user has to check in to coordinate their connection. And for a lot of backends, especially those built on older Python frameworks, this is where we find our first smoking gun. To really get what's going on, we have to talk about our prime suspect, the C10K problem. It's a classic. How does a single server possibly juggle 10,000 clients all at once? The old way of doing things, giving each user their own dedicated thread, is an absolute disaster for WebRTC, because those connections stick around for a long time. You'd literally burn through all your server's memory and crash way before you get anywhere near that 10K goal. Okay, check this out, because this visualizes the problem perfectly. On the left, you have a synchronous framework like Flask. It's kind of like a highway where every single car, even one that's just parked on the shoulder, takes up an entire lane. It's a recipe for a traffic jam from hell. But on the right, you have an asynchronous framework. That's more like a bullet train, efficiently zipping thousands of people along on a single super fast track. And boom, here's the evidence, plain as day. This is the crime scene. Look at that red bar for Flask. As you add more connections, the latency is fine for a little bit. Then it just shoots straight up to the moon. We call that the hockey stick of death for a real-time app. Meanwhile, look at the async app. It just cruises along, keeping latency low and flat, no problem. So, we've found the culprit. How do we fix it? Well, here's our first major breakthrough. And honestly, this is the best part. You don't have to tear down your whole application and start from scratch to solve this. I love this quote because it just nails the strategy. Moving from something like Flask to Quart isn't about rebuilding the car. It's about swapping the engine. Quart is designed to be API compatible, which means you get this incredible performance boost from an async engine, but you get to keep the car's body, the steering wheel, all the stuff you're already familiar with. And this engine swap isn't some crazy complex surgery either. It's really just a straightforward 4-step process. You swap out your imports, you make your functions async, you find any old-school blocking libraries and replace them with modern async ones, and finally you push any really heavy thinking off to a separate thread. That's it. That's your path to massive scale. So, we fixed the front door. Awesome. Our signaling server is now a fortress. It can handle thousands of users. No sweat. Case closed, right? Well, not so fast. Just when we think we're in the clear, our investigation reveals a plot twist. A second, much sneakier bottleneck lurking deep inside our own system. And this is where we have to ask ourselves a really tough question. Okay, so tons of users can now connect to our app. But what happens next? Can our internal services, the ones that are actually doing all the heavy lifting of managing the media streams, can they really keep up? And it turns out, this isn't just a hunch. Check out this number from Datadog. A staggering 70% of developers are unhappy with how their internal REST APIs perform. That's huge. That internal sluggishness is the next domino that's about to topple your entire real-time system. Okay, this right here is the key insight. You have to start thinking about your system as having two totally different zones. First, there's the signaling plane. This is the part that faces the public. It's designed to handle the messy, chaotic, unpredictable world of the web. But then there's the control plane. Think of this as your system's internal nervous system. It has to be structured, brutally efficient, and crazy fast. Because in here, every millisecond counts. And that realization leads us to our final game-changing breakthrough. For that internal control plane, for that need for speed, we need a totally different tool. We need a protocol that was literally born for high-speed, machine-to-machine communication. And that tool is gRPC. So what's the big deal with gRPC? Well, first, it uses HTTP/2, which is like having a multi-lane superhighway over a single connection. Then it uses something called protocol buffers to shrink your data into these tiny binary packages instead of bloated old JSON. And maybe coolest of all, it allows for streaming, so your servers can just push updates the instant they happen. No more asking, are we there yet? It's exactly what you need for real-time control. I mean, just look at this side-by-side comparison. For this specific job, our internal control plane, REST is just completely outmatched. It's like bringing a bike to a Formula One race. gRPC is purpose-built for this high-speed, high-efficiency environment. It's faster, it's lighter, and its contracts are rock solid. It's a no-brainer. So how do you get these two different worlds to talk to each other? You implement the gateway pattern. Your async Python app becomes this brilliant central orchestrator. It acts as a translator. It speaks fluent, flexible WebSockets to the chaotic outside world, then turns around and barks these clean, super-fast gRPC commands to your internal services. You get the absolute best of both worlds. And there you have it. After all that detective work, we've totally cracked the case. We have found the culprits, and now we have the complete blueprint for building a real-time system that doesn't just work, but one that actually thrives under pressure. So if you only take one thing away from this whole investigation, let it be this simple, two-part strategy. Pillar number 1, fix your front door. Use an async framework for your user-facing signaling plane. And pillar number 2, supercharge your internals. Swap out those slow internal REST APIs for high-performance gRPC. That's the secret. See, by solving both of these bottlenecks, the one on the outside and the one on the inside, you're not just plugging a leak, you are building an architecture that's truly ready for success. Hey, if you found this investigation helpful, do me a huge favor and share this explainer. And of course, give it a like. Thanks so much for joining me.